You hate coding, don't you? I hate coding. My best friend hates coding. Even my best friend's mom hates coding. And I bet even Mark Zuckerberg hated coding until he became a billionaire. Actually, to be honest, I used to hate coding until I learned a thing or two. Ever heard the saying, a good programmer is a lazy programmer? Yep, it's true, but not in the way you might think. You see, being a programmer doesn't mean giving up your life to stare at your computer all day and guzzling down endless cups of coffee. There's a parallel universe out there where programmers like me achieve efficient results, have a girlfriend and a life, and make decent money doing it. My mission is to show you how to work smart, not hard, and become a highly productive, lazy programmer. I feel like I'm starting to sound like a motivational speaker? That's beside the point. Right now, it's time to get straight into the action and take laziness to a level even your couch would be proud of. First, let's address the elephant in the room: problem solving. Programming isn't a contest to see who can recite the most syntax. It's about curiosity, persistence, and creating solutions. Let me say that again. Curiosity, your persistence, and creating solutions. So stop cramming like it's your high school chemistry final. Instead, focus on how to solve real-life problems. Problems that can be solved with codes. Imagine you're a developer thrown into a hackathon, tasked with automating the mind-numbingly dull data entry process for a startup. The tools and APIs are as familiar to you as quantum physics was to your dog. And you're on a tight deadline, because why not add a sprinkle of panic to your day? First up, you would assess the available tools. This is the conversation you would be having with yourself. Let's see. Should I use this API that I barely understand, or that one that has documentation written in cryptic runes? Choices. Then you'd break down the problem like you're explaining the plot of a complex sci-fi movie to a 5-year-old. It would go something like this. So the robots need to take over this part, and no, we don't let them take over the world. Yet. Next, you'd start prototyping a solution, piecing it together with the grace of a toddler building a Lego castle. It's functional, it sort of looks like what it's supposed to, and it hasn't fallen apart yet. Success. As you develop, you continuously test with sample data, and you would have lots of moments like this. Oh look, it crashed again, surprise, surprise. Adjusting the code becomes a game of whack-a-mole, where every bug squashed seems to spawn 2 more. But through it all, you keep your cool because, let's be honest, freaking out is only going to make you more afraid of your convoluted code you've written. Successfully automating the task with a script cobbled together under these conditions isn't just about flaunting your technical skills. It's a testament to your MacGyver-like ability to make things work when the pressure's on. It's not just coding. It's surviving on a coding reality show without getting voted off the island. This kind of on-the-fly problem-solving and duct tape engineering is what makes a great programmer. It's not the ability to memorize code, but the capacity to creatively use coding to improve things, and occasionally to save your own skin before the demo. Now that you've mastered problem-solving, or so you think, let me share a jaw-dropper fact. Without appropriate coding practices, the average software project can accumulate as many as 15 to 50 errors per 1,000 lines of code. That's like trying to solve the mystery in the game of Clue, but with half the clues missing. You might end up accusing the butler, the maid, and even the cat before figuring out it was Professor Plum in the library with the candlestick. But by applying best practices, that error count drops by 75%. You must say that's an impressive improvement for a few extra hours of being diligent. Let me break down these so-called best practices. This includes things like writing clean, readable code, using version control, and implementing automated tests. Sounds boring, right? But here's the truth. They save you from the endless cycle of debugging nightmare. For example, let's say you're developing a basic e-commerce website. Without best practices, you might name your variables like x, data2, or the infamous stuff. We all love that one, don't we? Also, you skip writing comments because you decide to be lazy and thinking that your future you will definitely remember do the thing was supposed to mean. Fast forward a few months and the checkout system is glitching. You're knee-deep debugging the commentless spaghetti mess of code with random variable names, saying to yourself, "What idiot wrote this? Oh, right, it was me." Now let's rewind and do this with best practices. First, you use meaningful variable names like total cart price or shipping cost, so it's crystal clear what each piece of code does. Then you sprinkle in comments like breadcrumbs, guiding your future self through the logic. On top of that, you add automated tests to ensure your checkout calculations don't implode after an update. And the result? Debugging becomes less of a nightmare, and you get to keep your sanity, and maybe even your weekend saved. Best practices might feel pain in the ass at first, but they're the difference between a project that was interesting, fun, and challenging, or the one that becomes a recurring character in your stress-induced nightmares. Here's another shocking insight for you. The software industry spends about $312 billion annually on debugging software issues, and that was billion, not million. To put that in perspective, that's the GDP of Denmark. For those that don't know GDP, it's a measure for how much money a country makes every year. So it makes you wonder if more coders used best practices. How much of the $312 billion could be spent on paying ISA developers? You should check out my other video about solid principles for more in-depth coding practices. Now that you've mastered best practices, let's talk using the right programming language. It's important to note that research shows that by switching from a lower-level programming language to a higher-level one can boost your productivity by a factor of 5 to 10 times. That's like having another 5 to 10 of you working with you. It would be super weird and cool. But imagine how much more coding you would do. For instance, think about coding a simple Hello World program. In C, it's like assembling a piece of furniture with a confusing manual and an all-too-easy-to-lose Allen key. Inevitably, you'd need to invoke the studio.h library and define the main function of the program. But guess what? After doing all of this tedious work, you'd still need to write the printf Hello World before finally bowing out with the return 0 statement. Now switch to Python. Suddenly, it's as if you've ordered that same piece of furniture, but this time it comes pre-assembled right out of the box. Just one line. Print Hello World, and there you have it. No sweat, no stress. This significant reduction in complexity means less time grappling with the basics and more time refining and optimizing your work. It's like replacing a pile of old remotes with a single app that controls all your media devices seamlessly, streamlined, straightforward, and stress-free. Now that you know which program is the right one for you, let's figure out how to level up your programming without actually increasing your effort. Because who wants to work harder, right? Enter AI tools, your new best friends, which you've already heard of some. For example, let GitHub Copilot carry the heavyweights. Ever found yourself scratching your head, trying to remember how to navigate a particularly tricky piece of code? That's where Copilot comes in. For example, let's say you're working on a new web application and need to integrate an API you're not familiar with. Instead of going through documentations or Stack Overflow posts or, better yet, YouTube videos, you start typing a comment in your code like, fetch data from the API. GitHub Copilot picks up on your hints and automatically suggests a chunk of code that handles the API request, complete with error handling. It's almost like magic, but you don't even need to rub a lamp. Stuck on a brain-busting algorithm? LeetCode is your new workout buddy. Need to write a function but don't want to sound like you just stepped out of a time machine? Claude will come to your rescue, making sure you sound less like a caveman and more like a nerdy developer. And here's a little secret that might just blow your mind. Using automation tools like Jenkins or Travis CI can improve your deployment frequency by up to 30 times, which leads to 50% fewer faceplants and production failures. Think of all that extra time you'll have. Enough to finally start fixing bugs or, let's be honest, to catch up on your Netflix marathon. Using these tools doesn't mean you're about to be replaced by a robot. Think of them more like your sidekicks, not the hero of the story. They'll guide you, but you're still the captain of your code. And now for the last trick up my sleeve for lazy programming, pair programming. It's just a practice where two programmers work together at one workstation. One, the driver, writes the code while the other, the navigator, reviews each line of code as it's written, providing insights and possibly directions. The roles can switch frequently or remain static, depending on the task or personal preference. This collaboration ensures immediate feedback, which reduces errors and improves code quality. It's like having a spell checker for your code, except this one can also grab coffee with you. Studies show that when developers pair up, they can reduce bug rates by up to 15% compared to coding solo. Plus, it usually takes them 15% less time to debug. Imagine you're stuck on a particularly nefarious bug that makes your code behave like it's possessed. Alone, you might end up talking to your computer in tones and words, usually reserved for your boss that you love. For example, suppose you and your coding buddy are working on a new feature that integrates a third-party API for a financial application. Alone, you might misinterpret the API documentation as easily as a toddler misinterprets a bedtime story. Together, you have 4 eyes and 2 brains to parse the jargon, meaning you're twice as likely to catch that sneaky detail about transaction limits before it goes live and empties someone's bank account during testing. This shared approach not only slashes the time spent facepalming at the screen, but also significantly reduces the chances of those "oh no" moments when you realize the code you wrote at 2 a.m. has more holes than Swiss cheese. But if you're flying solo and don't have a coding buddy, that's where a programming community comes in. Think of it as your virtual pair programming team, available 24/7. Got a tough bug? Someone on Stack Overflow has probably faced it and solved it before you. Want to learn a new language? Dev forums are full of people who will guide you, encourage you, and occasionally roast you for not knowing the basics. The community is always there, ready to help or give you a lighthearted jab when you mess up. So there you have it, my coding friends, the lazy programmer tips for you. Let me know what you think, and if you found this helpful, please don't forget to like, subscribe, and check out our other videos on the channel for more programming tips.